And Juliano, another question.
Yeah,
Can I record the presentation?
yeah, sure.
Okay, thank you.
By the way, you can share to us as well, right? So I think it's a good idea. So
Okay,
for the people that missed right the session, probably they could see that right later on.
okay, they can see in the
Yeah,
replay.
yeah.
Good.
That's a good idea. Hey, Dave.
How you doing?
Great.
Good. Helen does have the day off.
Okay. I think most people are here already. I think we can start, right? And let me do a quick introduction, right, about Cesar and the purpose of this lecture, right? So basically, back on 2004, right, I did my black belt training in the Whirlpool company with Cesar, right, a long time ago, right? And that is a guy that I really trust, right? And he moved even beyond me, right? And he did the master black belt, right? And all the certifications, and has been working for a long time on that, right? On that type of consulting, right? And as we are in the journey, in the transformation journey, right? And the data is so important to make decisions, right? Even for automation and whatever for sales, right? Then I decided to bring Cesar here just to share, right, some words of wisdom about that, right? So especially how to make decisions using data, right? The importance of that. And when I say data, right, is not just to do a complex line of experience, right? But sometimes a simple Pareto chart, right? So or a kung fu chart is enough, right? To see things, right? By using the data. So yep, just to support the best decisions. So, am I correct, Cesar? So correct if I'm wrong. So
That that's it. That's it, Juliano.
yeah, yeah. I think now we can start, right? So yeah,
Okay.
just carry on.
Okay. Hello everyone. My name is Cesar. Can you hear me? Okay. It's all right.
Yep.
My name is Cesar, and it's a pleasure for me to be able to make this presentation to you. First, let me introduce me and my company. I'm the founder of the company Learn Limitada, and for the last 13 years we have executed and mentored more than 2,700 projects in the most varied sectors of the industry, from pharmaceuticals, automobiles, paper, engines, fashion, footwear, clothing, among others. And maybe you know some of our clients, our main clients. Here are some of our clients that trust in our work. Maybe you recognize some of them, especially one of them here in my hometown that makes exactly the same products that you make there in Canada. This company is Claris, is from the Tigre Group. Maybe you have heard about them. They make these PVC doors and windows, the same product that you do on Canada. And what are we going to talk about in this 60-minute lecture? The first point is how critical thinking helps professionals in industries to achieve their goals. The second one is some practical examples of quantified gains and some graphic visual analysis on how this scientific methodology can help in our journey. The third point is use of data as basis for decision making and root cause discovery with one real extrusion example in the end. And the fourth point, and I think this one is the most important here, is the importance of good questions. So let's start with a real story. And I'm going to tell you a story that I tell in my book. The Industrial Scientist, unfortunately, is not available in English, but it is the book that we use for all our courses. This is a real story. Imagine you are in a company that makes PVC plastic injection molds for footwear industry, and you have 17 machining machines that work 3 shifts a day. They are operating at a full load, and the sales department tells you that in their forecast for the next year is for a 20% increase in sales. That's a very good problem, but still a problem if you are at a full load. And given this forecast, the company's operation director asks his technical department to create a budget to purchase 3 more machines to meet this demand. And although this company has already implemented all that little lean manufacturing principles and tools like total productive maintenance, you may know some of them, the quick changeover, the 5S for organization. They had all these principles implemented, and they also had a close relation with the raw material and the machinery suppliers, and their OEE, the overall equipment efficiency, reached global standards. So to buy those machines was really the solution. But there was a professional in the company who thought slightly different than the rest. He is a critical thinker. He had led an optimization project based on critical and creative thinking associated to the scientific method, which is the basis of the industrial scientist method. And his project brought to the machining company a decrease in 25% in the machining cycle time for the main parts of the mold. But how did he do it? This is what I call bringing science to industry. And remember, just a little parenthesis here. Remember that a scientist isn't that PhD guy that works in a university. A scientist is a state of mind, is a professional that deliberately seeks for knowledge. And in our case, this knowledge will be directed towards achieving our goals. And Eduardo, which was his name, he was the industrial scientist leading the project, and his mission was to avoid the investment on the three new machines. He reduced the machining cycle time, so the investment was not necessary anymore. And that's what the experienced senior manager told about Eduardo's work. Yeah, the quoted sentence here, he said that in 40 years of experience with machining, I had never seen anything like that, anything like Eduardo's project. And let me show a simple tool that can help every project to make better decisions. It is the thought map. It works like a guide that you let the questions lead the project. So at this point, you should be thinking about the quality of your questions. And I tell you, when you elevate the quality of your questions, you elevate your results. And you stop seeing me for a moment. And I'm not expecting you to read this map. It is just to show a little part of it and show how it works in a glance. I want to show you in this slide the dynamics between questions and answers, and also graphs, data, and the knowledge produced by this project. The main cycle here is the induction-deduction. Induction-deduction. It starts when you ask a good question. That's induction. And then you need to answer this question and make your deductions. You need to record everything, and you need to record everything in your thought map. And that's not my idea. This is Leonardo da Vinci's idea. So you may remember the famous Leonardo da Vinci's notebooks where he recorded everything. And this is the beginning of the knowledge management, which is very important to a company. Note that this tool can be used for different levels of complexity. The main point here is the questions generating data and knowledge. So how can we improve the quality of our questions? But before, just let me show you some graphical analysis that led Eduardo to good decisions here. Let's move on the map. And here I'm going to show you the dynamics between the squares you are seeing here. In the yellow square, you can see the question that is inducing the knowledge, and keep in mind that it all starts here. The question is inducing a plan, and in this case represented by a sample strategy. That little tree diagram on the bottom, I will show you here. Do you remember? It is a simple one, but the simple ones are the best. And after the question and the sample strategy, you can see a very simple graph that shows where to go, or sometimes where not to go. And for this particular machining example, it was the arch programming, the ones in the left, the 2 points on the left. The arch programming presented a big difference in relation to the point-to-point programming and the other ones. So they should stop using this program in the machining process. And here's an example of what they shouldn't do or stop doing. And you might be asking in your mind, that's quite obvious. It is in the graph. And I tell you, nobody in the whole company has ever seen a graph like that up to that moment. And the obvious is only obvious after someone asks a good question, plans a sample strategy to collect data, and show you a simple graph. And then the obvious arises. Let's move on here in Eduardo's project. And here is a graph that showed how to reduce the cycle time, this Pareto graph. This graph is a product of a multifactorial experiment designed by all the steps and decisions that Eduardo made during the project. The Pareto shows in order of importance what factor is the most important for the cycle reduction, and shows exactly which factor is most important and which factor is less important. And this is an example on how to make easy your decisions based on graph. But remember that it all starts with asking good questions. And in this case, this project avoided a huge unnecessary investment. But how can we make better questions? So let's move on to the other point on how can we improve this process of questions generation. And here I start talking with the critical thinking in industries. The critical thinking is one of the top skills listed by the World Economic Forum for the professionals of the future. Note, this skill has been on the list since 2005. And so this is not a skill for the professional of the future. It is a skill for today's professional. And something we noticed in the last 2,700 projects we mentored is that critical thinking is a skill that can be developed and refined through practice. And how can we refine? How can we refine this skill? And I'm going to tell you another real story that is in my book, The Industrial Scientist, and is an example on how we can make better use of critical thinking. This story is in the article I've sent to you, and it is about using critical thinking in people management. As I told you before, we work with project cycle in industries for product and process improvement. First, we define with the directors or our senior managers what indicators should be improved, and then we define some projects to help this indicator to improve. With the projects defined, we define the right professional to lead it, and then we start a training project mentoring according to the project's complexity. And this example was in a footwear company, and we were running the complex cycle in this company, which means that the people in that cycle had to prove they had already been certified in the intermediate cycle. There was, in that cycle, among the team, there was an industrial scientist that executed a brilliant intermediate project and had for the complex cycle more than $1 million in expected results for his projects. And for information, the complex cycle usually lasts around 1 year. But before moving on, just a quick talk about indicators here. You can see that here we've got a future indicator. We call a leading indicator. An indicator that helps the manager to look at the future, unlike lagging indicators that show the past. Managers often tend to focus excessively on lagging indicators, and there's not much time left to look at the future. Both are important, but you must strike a balance between the two, the leading and the lagging indicators. Managers should have leading future and lagging indicators, and here you see that is very clear. That is a leading indicator, which is the future $1 million results of the projects. And going back to the $1 million guy, Diego was his name, he had already demonstrated the ability to execute projects. But his senior manager came to me and said, "We have to fire Diego because he has one of the highest salaries on the team." And I asked, "Why do you have to fire him?" And he answered, "Because the CEO ordered 10% of the staff to be fired and other budget cuts to close the month's budget. And I need to start with the ones that earn more. Don't you know that a crisis is approaching?" He asked me. And I answered, "There is always a crisis," especially here in Brazil. There is always a crisis. I don't know there in Canada, but here there is always a crisis coming. And I asked him, how much does he earn per year? And the senior manager answered, he earns around $35,000 a year. And can you see he will deliver more than $1 million in the next 12 months? But I continued the question. Does he have any personal or behavioral issues? No, he is doing fine, but we need the budget cuts this month to avoid financial loss. And by the way, this $1 million you say, is only a promise for 1 year, and 1 year it is too far from now. And you understood. Contrary to my argument, he fired him. Can you believe that? A senior manager with 30 years of experience at the largest footwear company in the country did that. And this is what I call the 0.4 management in 4.0 industries. A great manager also needs to be a great businessman through good questions and critical thinking. It seems that in a crisis, the critical thinking is the first ability that some professionals lose. Remember, the CEO had ordered him to cut 10% of the budget, not to shut down your critical thinking. This is the great manager I call, but a terrible businessman. And a question for him is, do you drive looking at the rear view mirror? Is that okay so far? Questions? All good? And let's talk here about an example, and a product and process example here, which is an extrusion optimization. And here, in this time, a new refrigerator was to be launched, but during the approval tests, a lot of cracks in the door liners were found. And by that time I was the process engineer for the extrusion and thermoforming of this part. And I was the main responsible for the problem. This crack in the door liner, the door inside plastic part, had been found through a thermal cycling test. This cyclical test exposes the finished doors to temperatures ranging from -26 to 50 Celsius degrees, and after 10 cycles of 12 hours each, no crack should happen. And this was a company's global standard test. Just to make more clear here, this is one kind of crack in the door liner. And there had been happening a lot of cracks like that for the new product. This is a zoom photo that shows the cracks intensity. And some of them crossed all the door liner, and the consequence for the company was to change this door and sometimes the whole product, generating high costs. And then I started the project thought map with some basic questions. And often question generation can appear to be a random process. And it is helpful to note that questions come in both parallel and sequential manner. And according to the problem complexity, simple tools as 5 whys, you may know the 5 whys tool, can be helpful, but certainly not for this case. For this case, we should use the thought map, not the 5 whys, which is a linear tool. Here we have a quality improvement and cost reduction project. And again, just to take a look at the dynamics of questions and answers, here is the beginning of the thought map. That's the induction, deduction, knowledge cycle. And on the side here, you can see some of the initial questions for this project. Some initial questions were: what design and or process changes occurred just before this new product? Is this one really a new process or product? Did the previous door designs pass the test? Has the customer usage changed? Have the shipping practice changed? Have the raw materials been changed? This is an example of some questions I made in the beginning of the project. And by these questions, you can see that the focus is on finding out the root cause independently of the department, machine, what might be the cause. It is a true problem-solving approach, not a witch hunt. It is a problem-solving approach. And after the questions, the classic affirmations come. Some like that. The extrusion or the thermoforming or whatever process came out of control again. The previous product was approved. Why isn't this one? So this disapproval means the previous product is also disapproved. Some affirmations here. Let's go back to the previous design. Let's go back to the previous process parameters. And sometimes going back is not an option. And remember that without data, these are only opinions. And opinions don't help at all at this point. Good questions and data do. Good questions and data, not opinions. We don't want opinions. And can you see why we use the thought map? The thought map brings us data, actions based on logical sequence, answers, theories, parallel paths that help us in the investigation. And by the way, all the project team was waiting for an answer because the product must be available for sales next month, which was the Christmas sales. And another thing that almost always happens in this kind of situations is a functional overlapping due to the emergency situation. And in this, the directors hindered the technical team by demanding unnecessary tests that consumed unnecessary time and resources to get information that did not help very much the team. For example, one of the demands were to make 30 units like, quote, we used to do. I mean, going back to the original design, the original process parameters, then test these units, and if they pass our test specifications, then we've proven that the new design and our process changes are at fault. But the technicians weren't interested in finding the culprit. And even though we didn't think it was the best thing to do, we did. And the previous design didn't pass the test either. So panic. All our products are at risk, said someone. But this was not what the data from the customers were telling. We knew that something was very strange here. And we decided to run one multifactorial experiment with process and design factors like extruded raw material, extrusion tensioning, co-extrusion material, mold temperature, and so on. But when we were mapping the whole process, making the process map, I saw something that caught my attention. According to global standards, cotton oil must be applied on the plastic part of the finished doors to accelerate the thermal cycling test. I'm talking about the doors that were about to enter the thermal cycling test. And they passed cotton oil in the door surface to accelerate the cracks, or the possible cracks. And the lab technician had 2 cans of cotton oil, 2. One that was brand new, and the other one was about 4 or 5 years old. And I decided to also add this oil condition as a 2-level factor in the experiment, just to check. And one of the huge advantages of running a fractional multifactorial experiment is that you can define exactly what factors are more important and what factors are not. And here in the side you can see but you cannot read. You can see, and I'm not expecting you to read, just to give you a full view here. And here you can see this factor relationship diagram of the first and the second experiment, and we run a series of experiments to refine the knowledge about the factors, which is throw away the ones that are not important and learn more about the main factors. And here we've got the other FRD, which is the factor relationship diagram. And this one is for the second experiment. Here in the zoo, in detail, this factor relationship diagram for the second experiment with one revelation that we had here. As you can see in the Pareto plot, which is the interpretation of the experiment. After running the experiment, we collect the data and make graphs for a better decision. Here, the main factor in this second experiment was the oil, the cotton oil. Remember the age of the cotton oil? And remember, we tested extrusion, thermoforming, polyurethane injection factors, and in this second, and again, we tested 2 times because we couldn't believe that. The main responsible for the door cracks was a test factor, the cotton oil. The age of the cotton oil, serious? The age of the cotton oil was the responsible, or the main responsible, for the door cracks. And at this point, the project scope changed to discover what could be the ideal oil properties to change the global standards. Because all the company branches worldwide were using this test procedure, and they were for sure disapproving good products because of the oil quality. And the main thing here is always keep your critical thinking in the on mode, always active. Because maybe the global standard is the problem and not the process or the new design as everybody was thinking before. And the best in this experiment is that this project is that I run on the background a new raw material approval test, and it was approved. After fixing all that oil issues, we could approve a cost reduction because of this multifactorial experiment told us that this would be possible. And in this project, finally, we could solve a quality problem together with a cost reduction based on these simple graphs we generated after the experiment. And the experiment came from data, and the data came from the good questions. So if I was to say one thing, the main thing here is you should improve your questions, your everyday questions. And here I finished this example, and I am open to questions. If you want, Juliano, anyone?
For that case, you did use which software to process that?
There are a lot of softwares you can use, and all these softwares are mainly for data analysis. Yeah, you can use the Jump from SAS. You can also use Minitab and the IBM SPSS, and you can use, for example, we have a software, our company also has a software that helps people not to just analyze, but also to plan, which is the most important thing here, the planning before analysis. Because after you have the data, so the only thing you can do is to analyze, because the data is already there. But the main point is, how did you collect this data? That's the main point. How did you plan this data collection?
My next question is, what's the best approach to start that investigation, right? The big picture to start that, to provoke, right, that.
Yeah, I showed you here. Let me go back to the presentation. That you start with some questions, some initial questions, but one thing you should avoid is these classic affirmations I presented here, because these affirmations often come from other people that work in other departments, but you should consider these affirmations as opinions, and these opinions shouldn't influence you. What should influence you is the data you collect.
That's great. And probably you can start even from a simple graph, right? Bar chart or some Pareto chart, right? Just to quantify that, right? So the big picture.
Yeah, the main point here is the questions, and sometimes you want to run directly to the answer without asking some questions. And the main point is to make good questions to drive a good data collection, and then you can generate good graphs, and only after that you can make good decisions, or you can make better decisions